Jai Hind students, welcome to my YouTube channel. Students, there are 5 W's of life. Yes, there are 5 W's of life, and they are who, what, when, where and why. Now let me elaborate it. Who you are is what makes you special. Do not change for anyone. What lies ahead will always be a mystery. Do not be afraid to explore. When life pushes you over, you push back harder. Where there are choices to make the one you won't regret. And students, why things happen will never be certain. Take it in your stride and just keep marching ahead. So these are the 5 W's of life. Right, students? So with that, let's begin our session. Today we are going to discuss some very interesting numericals based on electricity. Basically, these are the 4 questions which we will be discussing in this particular lecture, right? In each of these questions, we are supposed to find out the current flowing through each resistor and the potential difference across each resistor. These are the circuits involving the parallel grouping, series grouping and the mixed grouping of the resistors. I repeat, students, in each of these 4 questions, we will try to find out the current flowing through each of the given resistor and also the potential difference across each of the resistor. So let's start with the first question then. Okay, just concentrate on the circuit diagram of the first question. It's 10 and 20. These two are connected in series. 5 ohm, 25 ohm, they are connected in series. So basically, in such questions, we need to find out the net resistance of the given circuit. And students, you are aware, in series grouping of resistors, the current always remains constant and the potential difference across different resistors is different, isn't it? While in parallel, students, you must remember, in parallel, the potential difference across the ends of the conductor connected in parallel will always remain constant. But the current flowing across different resistances would be different. And also, we are aware of law of combination of resistances in series. When 2 or more resistors are connected in series, then the resultant resistance is given by R is equal to R1 plus R2 plus R3 and so on. While in case the resistors are connected in parallel, then the resultant resistance is given by 1 by R, it's equal to 1 by R1 plus 1 by R2 plus 1 by R3. Isn't it? We all are aware of these basic things. So, let's try to get the answer to the first one. Now, there is no doubt that these two are connected in series. So, in series, the formula is R is equal to R1 plus R2. This is the formula for series. It is R1 plus R2. While in parallel, this is the formula. 1 by Rp equals to 1 by R1 plus 1 by R2. So, if you solve it, Rp, it would give us R1 R2 divided by R1 plus R2. So, this is the case of series grouping of resistors and this is the formula to be used for parallel grouping of resistors, right? So, these are connected end to end, right? So, they are connected in series. So, the resultant of 10 and 20 in series would be 30 ohm, no doubt regarding this. Similarly, students, 5 ohm and 25 ohm, they are also connected in series. So, the resultant resistance would be given by this formula 5 plus 25. So, that will give us 30 ohm. So, it's like this. This will give us 30 ohm. And it is connected across a potential difference of 12 volt. It can be written like this, 12 volt. Clear, students? Now, these two are connected in parallel. So, what will be the effective resistance? So, effective resistance in parallel would be given by R1 R2 divided by R1 plus R2. And we have discussed, students, if the two resistors of equal resistances are connected in parallel, then their equivalent resistance becomes half of the given value. So 30-30 parallel will give us 15. Let's check it out. So here net resistance would be given by the parallel grouping of these two. So using this formula we get 30 into 30 divided by 30 plus 30. So it will be 900 divided by 60. So it will be equal to 15 ohm. So you can write the result directly as well, right? Whenever the two resistors are having same resistances and are connected in parallel, then the resultant resistance will become half of the given value. So 30-30 parallel, it will give us 15 ohm. So net resistance is 15 ohm. So that's the first part, right? In each of the four questions, we are supposed to find out the effective resistance of the circuit. Second, the current flowing through each of the branch. And third is the potential difference across each of the resistors. So net resistance has been calculated. It's 15 ohm. Now students, net potential difference is 12 volt. So these two are connected in parallel. So here also, across 30 ohm resistor, the potential difference is 12 volt. And here also it will be 12 volt. Isn't it? So net current, it will be equal to net potential difference divided by net resistance. We are aware students, V equals to IR. So net current would be net potential difference across the combination divided by net resistance. So net potential difference is 12. Net resistance is, students, 15. Isn't it? So it is 4 by 5. So it is 0.8 ampere. So this is the net current flowing through the circuit. This is the net current. This is 0.8 ampere. Now what about the potential difference across this branch? It is 12 volt. Here also the potential difference is 12 volt because these two are connected in parallel. Students, in the parallel grouping of resistors, the potential difference always remains constant. And basic formula is V equals to IR. Out of these three, if the two are known, then the third one can be easily calculated by using this formula V equals to IR. So here, R is given 30, potential difference is given 12. So therefore current, suppose it is I1, passing through this branch, it will be given by 12 divided by 30. Which formula I have used is I is equal to V by R, right? So across this resistor, potential difference of 12 volt is given. So it will give us 4 by 10. So it will be equal to 0.4 ampere, right? So in this branch, a current of 0.4 ampere flows. 0.4 ampere. These two are in series. Therefore here also the current flowing must be 0.4 ampere. In series, the current flowing through each of the resistor connected in series must be same. Now, what about the current in this branch? The net resistance of this branch is also 30. So here also the current must be same. You can check it. Here the current is suppose I2. It will be equal to V2 divided by R2. Potential difference is 12 and net resistance of this branch is 30. So it will be again 4 by 10. It is 0.4 ampere. So here also current is 0.4 ampere. So students, as I told you, this point will act as a junction. 0.8 current is entering this junction. So some of the currents leaving this junction should also be equal to 0.8. You can verify it. So 0.8 ampere is entering this junction and 0.4 plus 0.4. The sum of these two leaving that junction would also become 0.8. So junction rule is valid. So our answer is appropriate. So what we have done is, we have found the current flowing through each of the resistor, isn't it? In series, the current always remains constant. And 0.4, 0.4, it will combine together at this junction. These are the two currents entering this junction. So sum of these two currents would be equal to the current leaving it. So it will be equal to 0.8 ampere. Clear? Now potential difference across each of the resistors. Now look, potential difference across 10 ohm. Potential difference is I into R. What is the current? 0.4. What is the resistance? 10. So it will be equal to 4 volt. Potential difference across this resistor is 4 volt. What about this? PD across 20 ohm. V is equal to IR. So current flowing through the 20 ohm resistor is 0.4 ampere and resistance value is 20. So it will be equal to how much? 8 volt. So here the potential difference is 4 volt and across this resistor the potential difference is 8 volt, and 4 plus 8, that will give us 12 volt. You can cross check it. Right? In series, the net potential difference across the combination V is given by V1 plus V2. That is what we have verified over here. Similar students, the potential difference across 5 ohm, it is equal to current flowing through 5 ohm is 0.4 multiplied by 5. So it will be equal to 2 volt. And potential difference across 25 ohm, it will be equal to 0.4 multiplied by 25, that is 10 volt. So again, here the potential difference is 2 volt and across 25 ohm the potential difference is 10 volt. So again 2 plus 10, that will give us the net potential difference, which is 12. So we have obtained all the answers. The current flowing through each of the resistor, the net resistance, and then the potential difference across each of the 4 resistors. So now the solution is complete, right? So students, we are over with question number 1 then. Let's concentrate on question number 2. We will follow the same method, right? We'll first try to find out the net resistance and then we'll distribute the current using the concepts of series and parallel grouping of resistors. Okay, second question is, concentrate on the circuit diagram. These 3 resistors, it is but obvious, they are connected in parallel, they are connected across, so they are connected in parallel. The ends of all these resistors are connected to the same points, these two. So across each of them the potential difference is 6 volt. So they are connected in parallel. So what will be the formula for the net resistance? It will be 1 by 2 plus 1 by 5 plus 1 by 10. So 10 can be taken as LCM. So 5 plus 2 plus 1. So it will be 8 by 10. Therefore students, net effective resistance of the circuit would be 10 by 8, that is 5 by 4, that is 1.25 ohm, right? So net effective resistance is 1.25 ohm. So what about the current then? Net current flowing through the circuit. It would be equal to net potential difference divided by net resistance. This is the basic formula, V equals to IR. So net potential difference is across the combination 6 volt. Net resistance is 5 by 4. So 5 and 4. So it will be equal to 24 by 5. That is 5 4 is 20, 5 8, 4.8 ampere. Clear students? So net current, it is 4.8 ampere. Net current flowing is 4.8 ampere. Now look students, as I told you, all the 3 resistors are connected in parallel. In parallel, the potential difference across each of the resistor must be constant. So here, the potential difference is 6 volt, same as that of the applied voltage. Across the 5 ohm resistor, the potential difference is again 6 volt, and across the 2 ohm resistor, the potential difference is again 6 volt. Isn't it? So let's find out current across 10 ohm. Suppose it is I1. So it will be equal to V1 by R1. What is V1? What is the potential difference across 10 ohm resistor? It is 6 volt. And what is the resistance? That is 10. So it is 0.6 ampere. Clear students? So the current flowing through this is 0.6 ampere. It is 0.6 ampere. Similarly, 5 ohm resistor. It can be considered to be I2. It is V2 by R2. Again, the potential difference across the 5 ohm resistor is again 6 volt. Same. And what about the resistance? It is 5. So it is 1.2 ampere. Right? And lastly, the current across 2 ohm resistor. Suppose it is I3. It is V3 by R3. V3 is 6. Again I repeat, potential difference across each of these resistors connected in parallel must be constant, same as that of the applied voltage, which in this case is 6 volt. So R3 is 2. So it is 3 ampere. So here the current flowing is 3 ampere. Here the current flowing is 1.2 ampere. Basically you can cross check it, whether the answer obtained by you is correct or not. Look, this is a junction. What is the current entering? It is 4.8 ampere, isn't it? I should be equal to I1 plus I2 plus I3. Let's check it. I, that is the current entering the junction, is 4.8. And I1, I2, I3 are the currents leaving this junction. So their sum must be exactly equal to the current entering the junction. So what will be the sum of these currents? 3 plus 1.2 plus 0.6. That is 4.8. So answer is perfectly correct, isn't it? So I, net current, it will be equal to I1 plus I2 plus I3 in the parallel combination, which is 0.6 plus 1.2 plus 3. Solve it, you will get 4.8 ampere, which was the net current obtained directly by using net resistance, isn't it? So the answer is an agreement. So therefore you can cross check such questions. After obtaining the result, you can cross check such questions, right? So what we have done is, we have found the net resistance of this grouping, we have found the current flowing through each of the resistor, then we have found the potential difference across each of the resistor, which in case of parallel, in this case, remains constant, same as that of the applied voltage, which is 6 volt, right? So we are over with question number 2 as well, students. Okay, now let's concentrate on question number 3. It is again a case of mixed grouping of resistors. It is the case of mixed grouping of resistors. So let's try to solve it. Third one. Okay, this is it. I will draw the circuit diagram again. This is 6 ohm. This one is 3 ohm. And the net potential difference applied is 6 volt. Now look, there is no doubt, students, these two are connected in parallel, isn't it? So its equivalent diagram would be 4 ohm. These two are connected in parallel, therefore resultant of these two, right? It will be given by 6 into 3 divided by 6 plus 3. So it is 18 by 9, that is 2 ohm. So their equivalent resistance is 2 ohm. So these two are in parallel, so the resultant is 2 ohm. Like this. So the circuit can be redrawn in this particular manner. Clear, students? Now, next. Now these two are connected in series. So 4 and 2 in series, it will give us 6 ohm. Okay, this is 6 volt. Got it, students? So what is the net resistance? 6 ohm. So let's find out the net current then. What will be the net current? V equals to IR. So out of these three, V, I and R, if the value of 2 are known to us, then the third one can be easily determined. Here, net resistance is known, net potential difference is known. So net current would be equal to net potential difference divided by net resistance. So what is it? It will be equal to net potential difference is 6, net resistance is 6 ohm. So it will be equal to 1 ampere. Right? So the current is equal to 1 ampere. Clear, students? Now let's proceed in the backward direction. 6 ohm. Students, please do concentrate how I am dealing with such questions, right? You need to follow the same procedure. So 6 ohm is the series of these two. Now students, 1 ampere current is flowing through the 6 ohm resistor, which is the series grouping of 4 and 2. You are aware, in series grouping of resistors, the current is always constant. So this 1 ampere must be flowing through each of the two resistances, 4 ohm as well as 2 ohm. Clear, students? So here, what will be the potential difference across 4 ohm? Resistance is known to us, current is known to us. So V equals to IR. So potential difference across this would be I, that is current is 1, and potential difference is 4 volt, because 4 into 1, V equals to IR. So it will be 4 volt. What about the potential difference across the 2 ohm resistor? Again, use the formula V equals to IR. Current is 1 and resistance is 2. So it will be 2 volt. And you can cross check it. In series, net potential difference across the combination is equal to V1 plus V2. Look, V is equal to V1 plus V2. It validates 4 plus 2 is 6 volt. So it validates our answer, isn't it? We are going perfectly okay. Now, the reverse step. This 2 ohm is the parallel grouping of these two. 2 ohm is the parallel grouping of these two. Therefore, in parallel, potential difference is constant. Across 2 ohm, the potential difference is 2 volt. Therefore, across 3 ohm resistor as well as across 6 ohm resistor, the potential difference would be 2 volt, because 2 ohm is the parallel grouping of 6 ohm and 3 ohm. Therefore, the potential difference across the 2 ohm, which is 2 volt, it should be same as that across the 3 ohm resistor as well as that of 6 ohm resistor. So basically, students, we are making use of two very basic facts. In series, current remains constant. In parallel, the potential difference remains constant. Right? Now students, here we are aware the current flowing is 1 ampere, isn't it? Potential difference over here is 4 volt, and here across the combination is 2 volt each, right? Now what about the current over here? Potential difference across this resistor is known to us, resistance value is known to us, so current would be V by R. V is 2 and R is 3, so 2 by 3 ampere. Clear? What about this case? Again, current is V by R, 2 by 6. So here the current would be 2 by 6. This is the potential difference and this is the resistance. So it will be equal to 1 by 3 ampere. So you can check it. This is the junction. 1 ampere current is entering. So it will get divided into two branches, I1 and I2. So I would be equal to I1 plus I2. Solve it, 1 by 3 plus 2 by 3, you will get 1 ampere only. So junction rule is also obeyed. So basically what we have done is, first calculate the net resistance of the circuit and then follow the reverse step. You will get each and every answer. Here what we have found is, we have found the current flowing across each of these three resistors. We have found the potential difference across each of the three resistors. So the current flowing across this is found to be 1 ampere. The current flowing across the 6 ohm resistor is found to be 1 by 3 ampere. 1 by 3 ampere. And the current flowing through the 3 ohm resistor is found to be 2 by 3 ampere. And how to check it whether it is correct or not? This is a junction. Net current entering this junction is 1 ampere, isn't it? So the currents leaving this junction, the addition of the currents leaving that junction must also be equal to the current that is entering that particular junction, which should be 1 ampere. So 1 ampere is entering and 1 by 3 plus 2 by 3, that will give us 1 only. So it's perfectly okay. Again, here 1 by 3 ampere and this is 2 by 3 ampere. These are the two currents entering this junction. So some of the currents entering a junction must be exactly equal to the current leaving the junction. So 1 by 3 plus 2 by 3, that will give us 1 ampere. Right? So students, we are over with question number 3 as well. So let's proceed to the last question. Last question is, the case of the series grouping of the 4 resistors. Fourth one. All the resistors are connected in series, and in series we are aware of the formula, students. The formula is R net equals to R1 plus R2 plus R3 plus R4. So that will give us 10 ohm. Clear? So this circuit can be redrawn in this manner. So this is 10 ohm and this is 12 volt. So what is the net current flowing through it? It will be equal to net potential difference over net resistance. So that is 12 divided by 10. So that is 1.2 ampere. So current flowing through the circuit is 1.2 ampere. Clear, students? Now look, this 10 ohm is the series grouping of these 4. And in series, current always remains constant. Therefore, same current 1.2 ampere must be flowing through each of the 4 resistors. Same current must be flowing across each of the 4 resistors. Right? Now, in order to find out the potential difference, we are aware of the current as well as the resistance. So, let's find out the answer. PD across 1 ohm is, suppose it is V1. I1 into R1, that is 1.2 into 1, that is 1.2 volt. Clear, students? Similarly, PD, potential difference across 2 ohm, is V2 is equal to, current is 1.2, V is IR, current is 1.2 and it is 2. So it will be equal to 2.4 volt. PD across 3 ohm is V3. Again, current I multiplied by resistance is 3. So it is 3.6 volt. Right? And lastly, PD across 4 ohm is V4. It is equal to, current is 1.2 and resistance is 4. So it is 4.8. Okay, let's cross check the answer. The net potential difference across the combination is V1 plus V2 plus V3 plus V4. So that will give us 1.2 plus 2.4 plus 3.6 plus 4.8. Right? If you solve it, it will give you 12 volt. So students, in series grouping, it verifies the fact that the net potential difference across the series grouping is given by V1 plus V2 plus V3 plus V4. So look, here it's 12 volt. So here the potential difference is 1.2 volt. Across 2 ohm, the potential difference is 2.4 volt. Across 3 ohm, the potential difference is 3.6 volt. And across 4 ohm, the potential difference is 4.8 volt. So if you add V1, V2, V3, V4, you will get 12 volt. Right? So that is how you can cross-check your answer. So students, I do believe that you must have enjoyed doing these questions, right? So be confident in doing such questions and you will gain in confidence only when you attempt doing such numericals more and more. Practice more and more numericals, right? So that's it for this particular session. Do join me in my next lecture then. Till then, goodbye and do take very good care of yourself. Thank you.